Let's talk about some common network attacks. The first type of attack we're going to look at is IP spoofing. IP packets provide a standardized form for data from different locations to be transmitted or shared over the internet in sessions. These protocols determine how data packets can be addressed to the intended destination, how they're routed, and which address they're being sent from. A session is a temporary, interactive communication between two or more systems, such as a client and a server, and spoofing is the process of masquerading as another identity. With IP spoofing, a packet's source IP address is changed. There are a couple of key reasons an attacker might want to do this. One reason is to hide the attack's origin. If an attacker sends an unmodified packet to a victim, the victim will know the attacker's IP address. The attacker knows this, so they change the packet's source IP address, which helps him or her cover their tracks. Firewall circumvention is possible if the attacker impersonates a trusted source in the header's IP source address. This is what prevents detection. Once the attacker gets past the firewall, the IP spoofing attack can take several forms. The most common one is an on-path attack. An on-path attack is a real-time attack on a live TCP session. Let's say we have a client and a server that are communicating with each other. The attacker intercepts the communication stream between the two, and simultaneously, the attacker's computer tricks the client into thinking it's the server and tricks the server into thinking it's the client. Another common form is DNS poisoning, sometimes called a DNS amplification attack, which relies on IP spoofing to cause a distributed denial of service to the victim. Let's look at how it works. The DNS, or the domain name system, is the Internet's address book. It's used to find the IP address of domain names that are easier for people to remember. So when you type in a domain name into your browser, it connects with a DNS server to return the IP address. This is what allows your computer to connect with sites online. But, just like anything, this process can be exploited. There are DNS servers that rely on User Datagram Protocol, or UDP, to process IP address requests. UDP is designed as a connectionless protocol so that it can process requests quickly. This means that it doesn't verify whether requests are valid or if they're received. So attackers can take advantage of this by taking 3 steps to create a DNS poisoning attack. First, they request more than just the IP address, potentially returning up to 50 times more information. Second, they spoof their source IP address to be the victim's IP address. Third, they repeat steps 1 and 2 multiple times. The result is that the multiple requests are answered with up to 50 times the data volume, and all of this data is sent to the victim's IP address. This can overwhelm the victim's site and cause a denial of service to valid customers or users. A third common IP spoofing attack is masking botnets. Botnets were designed to perform repetitive tasks to keep websites functioning properly. Because they're interconnected devices that run in the background, they're often a tempting target. If an attacker can spoof a botnet's IP address, they can bypass a lot of security programs. The botnets can then be used to perform malicious activities like gaining access to servers or domains. Another thing to look out for is MAC spoofing. Networked devices each have a factory-assigned identification number called a MAC address that's hard-coded onto their network interface controller, or NIC. This can't be changed. These addresses are used as a network address for communication, access control, or tracking. MAC addresses are found on wireless and Bluetooth devices as well. On wireless networks, filtering can allow devices that have specific MAC addresses. Now, while the MAC address on the NIC can't be altered, the drivers and software that are used for communication between hardware and operating systems can be manipulated. This spoofing is done by modifying a frame's source MAC address. An attacker can use this to replace the MAC address on his or her computer with the MAC address of an accepted device. Other times, an attacker might use it to bypass a router's access control list or to bypass port-based security on a wired switch. Another closely related form of spoofing is ARP spoofing, which is also called ARP poisoning. The goal of this attack is to associate the MAC address of the attacker's computer with another computer's IP address. This causes traffic intended for the original computer to be sent to the attacker's MAC address instead. This attack exploits the fact that a switch is a layer 2 device which only looks at MAC addresses and not at IP addresses. It fools the switch into redirecting frames to the wrong machine. For example, the attacker could execute this attack against the network segment's default gateway router to capture all outbound data. If the attacker were to associate their computer's MAC address with the default gateway's IP address, they could intercept all traffic being sent to the internet. We often see this used to enable an on-path attack. In this scenario, the attacker in the middle could intercept traffic and tamper with its contents before sending it on to the real destination system. Alternatively, the attacker could just drop the traffic altogether, or they could simply sniff the traffic and allow it to reach its destination without tampering with the contents. Now, let's discuss one last attack called a rogue DHCP server attack. DHCP servers assign IP addresses to requesting devices. The IP address assignments allow devices to communicate with each other. If a second DHCP server is introduced onto the network, any clients requesting a connection receive IP assignment offers from both the legitimate DHCP server and the rogue DHCP server. If the client accepts the IP address assignment from the rogue server, it can cause multiple issues. For example, an attacker can have all the client's default gateway traffic routed to his or her own computer. It can also cause sluggishness on the network or the inability for hosts to communicate with each other. To prevent a rogue DHCP server from running on your network, you can use a technique called DHCP snooping, which drops DHCP traffic from an untrusted server. DHCP snooping can be configured on switches to remove any unwanted DHCP traffic and to prevent any rogue DHCP servers from issuing their own IP assignments. You can also use intrusion detection systems to check for trusted signatures. That's it for this lesson. In this lesson, we talked about some of the common attacks that take advantage of TCP/IP's unsecure nature. First, we looked at IP spoofing attacks. Within that, we looked at on-path attacks, DNS poisoning, and botnet masking, which all use IP spoofing as part of their technique. Next, we discussed MAC spoofing and how attackers can manipulate drivers to alter frames. Then we talked about ARP spoofing, which fools switches into associating MAC addresses in their caches with the wrong IP address. And finally, we looked at how rogue DHCP servers can be exploited to redirect or disrupt network traffic.